A quick word about cationic acids. So in some cases, acids will be species that already have a positive charge on them. Very often this will be a nitrogen atom or an oxygen atom, and they will have an extra hydrogen than normal, kind of like you see here in the picture. And in these cases, you can almost automatically make an assumption about which will be more stable without thinking about what the base looks like. We can simply think about where the positive charge in this case is more stable, and it's a bit of a reverse of the negative charge, just like maybe you would expect. So when a positive charge is centered on a nitrogen atom, that molecule is more stable than when a positive charge is centered on an oxygen atom. And so therefore we can say that weaker acids or nitrogen atoms with positive charge, those protons are weaker acids than oxygen atoms that have a positive charge like you see here, because the hydrogen is less likely to leave that position from the nitrogen than it is from the oxygen. And then just one more point of note, even though the negative charge, so when these types of species lose their bond to that hydrogen, they go from positive to neutrally charged, so there's no negative charge there, but the lone pair is still there, and you should still check to see if that lone pair has resonance, particularly if they're on the same atom. Like sometimes we'll see maybe two different nitrogen structures compared to one another, and in the first case without the ring structure, we see a lone pair that has no resonance. So that molecule is less likely to give that hydrogen up because the lone pair is not resonance stabilized. Whereas in the case of the aryl version of that molecule, we end up with a lone pair that is resonance stabilized. So it's a little bit easier for that molecule to give away one of those hydrogens and leads to stronger acids like you see in the examples we have pictured here.